Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3 for October-November 2024, Paper 3-1, Part 2, that is from questions 6 to 10. Question 6, the diagram shows the curve y is equal to sine of 2x, then into 1 plus sine of 2x for x ranging from 0 to 3 pi over 4. 3 pi over 4 is the same as 3 times 45, which is 135 degrees, which is in the second quadrant, and its maximum point M, the shaded region bounded by the curve that lies above the x-axis, and the x-axis itself is denoted by R. This is the one up here. Then there's a part A, given that the x-coordinate of M lies in the interval between 90 and then 135 degrees, find the exact coordinates of M. Find the exact coordinates of M. This being a minimum point, it means it is a stationary point. So this one is a stationary point, okay? Even this one, the way it is, looks like it came like from something. So this can be a stationary point, this one here, and also this one here, because the curve is curving off. So that means when we solve this and we get the first values, okay, we can get this one here. Okay, this one we are not sure whether it is a stationary point, but at least this one is curving off. So maybe this one can be the first x value, then the second one, like that. So we are going to differentiate and equate to 0, okay? Because you know, for stationary points, dy dx is equal to 0. So here we are going to have our y. I can open the brackets and then say y is equal to sine of 2x, then plus, when you multiply, you get sine of 2x, then bracket squared. But I can write this one as sine squared 2x, okay? I have a reason as to why I've written this. Now, we differentiate this one. So dy dx, when you differentiate sine, you get positive cosine, cos of 2x, but you enter inside, you also differentiate the angle, and then you multiply through. So we shall have 2 cos 2x, then plus. Here, I'm going to differentiate, I take this one down, so I'm going to use what we call the chain rule. So drop that power, you remain with sine 2x, then reduce that power by 1. So it remains with power 1, okay? Then times. Now enter inside and differentiate this sine 2x. Already we have gotten it here as 2 cos 2x. So I multiply by 2 cos 2x. Then this one I'm going to equate it to 0, okay? Now we can see that 2 cos 2x is actually common. That means I will have a 1 here, then plus 2 sine 2x, which is going to be equal to 0. So meaning 2 cos 2x can be equal to 0, and then our cos of 2x is going to be equal to 0. If you divide through by 2, then the 2x is going to be the arc cos of 0, and then your x is going to be a half. Arc cos of 0, that is 90, which is pi over 2. Then we have also 270, that is 3 pi over 2. So meaning the answers we have here are pi over 4, and then 3 pi over 4. Then this other one is 1 plus 2 sine 2x, which is equal to 0. Take the one the other side, it will be a negative. Then after you divide it by 2, so we shall get sine 2x, which is equal to negative a half. And then 2x is going to be the arc sine of negative a half. And then our x is going to be a half, then times the arc sine of negative a half. Now, sine is positive in the first quadrant, okay? Sine is positive in the first quadrant and second quadrant. So I always use this. Let me try to put it a bit down. You can have something like that. So ASTC 0, actually now this one is in radians, I can just write 0, Then here 90 is pi over 2, and then pi here, then 270 is 3 pi over 2, and then here we have 2 pi. Now, if I have my x here, that will be the one, and then I project it here, the x will be here, so that means here we shall have pi plus x. And then if I put this x here, we shall have now 2 pi minus x, means you are moving like this up to here, okay? Then also this other one here, it will be x here, that means we shall have pi here minus x, okay? If you move from here up to there. All right, then so sine is negative here and here. Sine is negative in the third quadrant and fourth quadrant. So when I press the arc sign of negative a half, it is going to give me negative 30. Okay, but ignore the negative and you press arc sign of negative of just a half. It will give you 30 degrees, which is pi over 6. Okay, so you go to the quadrants where sine is negative. It is here in the third quadrant and fourth quadrant. So we shall have that pi, then we add that 30. Okay, pi over 6, and then the other one is going to be 2 pi minus pi over 6. Others can also use the sketch. Okay, but I use these 4 quadrants. It is easier to understand rather than but even sketching is also easy, no problem. Now when I get pi plus pi over 6, I'll get 7 pi over 6. So that means times a half, I'll have 7 pi over 12. And then 6 times 2, you get 12 minus 1, that is 11. Then that is 11 pi over 6. Now times a half, we shall have 11 over 12 of pi. Now, those are the values of x that we have gotten. Okay, by the way, this is 12 here. Those are the values of x we have gotten, but which one is the one for x? I mean for m. They told us that m, they gave us a range here. The x coordinate lies within this one here. It's bigger than 90, less than 135. When you look at this one here, it is 135. So these two, we shall cross them out. Okay, and then when we come to this one, 7 over 12, 7 out of 12, and then we multiply by pi is 180. So that's 105, which is less than 100, and it is bigger than 90 and less than 135. But when you get 11 out of 12 times, that's 165. So it is beyond the 135. So our answer, the x coordinate, has to be this one here, the 7 pi over 12. Now we use that to find the y coordinate. Okay, so the y coordinate, so we can say for x, which is equal to 7 pi over 12, okay, what will be now the y coordinate? So the y coordinate, you substitute, it is going to be sine of 2x, so that is 2 times 7 pi over 12, then plus sine of that 2 times 7 pi over 12, then we square it. Okay, we square it. Remember, I opened the brackets, and this is what we are having here. So you can even leave it out as a negative. Okay, you can leave it out as the way it was given when it is a product, just like that, and you substitute, you still get the same thing. Now sine, I can actually just change my calculator to radians. So press shift, then mod, rad is 4, and then I can put sine of 2, then 12 here, up there 2 times 7 of pi. This one gives us negative a half. So we have negative a half, okay, Here it is negative a half of pi. No. There is no pi, sorry. It's negative a half. And then plus, now that negative a half squared. So that is a quarter. Okay? A quarter. So negative a half plus a quarter, you get negative a quarter. It's like getting, okay, a quarter is smaller than a half. So when you say a quarter minus a half, 2 halves is a quarter. So this one will give us negative a quarter. So meaning the coordinates of M are going to be 7 pi over 12. And then the y coordinate is negative a quarter. That is what we are going to have. Part B, find the exact area of the region R. Now, when you look at the region R, okay, let's take a look through it. The region R here, we need to find the x coordinate where this graph cuts, yes, the x-axis. So we need to get this x coordinate. And on y-axis, we know that y is equal to 0. So we need to first get that limit because we are supposed to integrate from 0 here, then to this x value here, which we need to find, okay? So we shall, now we look for that value on y-axis, okay? On y-axis, sorry, not on y-axis. On x-axis, y is equal to 0. So I'll get my y, which is sine, into 2, sine 2 of x into 1 plus sine of 2 of x. Then I equate it to 0. So this means that the sine of 2 of x is equal to 0. Then the 2x is equal to the arc sine of 0. And there we can have 0, okay? We can have 0, we can have pi, we can have 2 pi. All of those can give us 0, okay? So that means here we shall get 0, then pi over 2 and divide through by 2, then pi and the rest. And then this other one is 1 plus sine 2x, which is equal to 0. So we take the one the other side. That means 2x is going to be the arc sine of that negative 1, okay? And then our x is going to be a half. Arc sine of negative 1, we have the 270, which is 3 pi over 4, okay? And others. So this one can actually give me 3 pi over 4. And this is the one that I'm going to take. So I can take 0 and then 3 pi over 4, okay? 3 pi over 4. Now you can check what we are having here. M, the x coordinate is 7 pi, okay? 7 pi over 12. And we saw it is 100 and what? 105. This is 135. You see that? Okay, then we have gotten 0 where it is cutting the y-axis. So there is this 0 here. Then the other one is pi over 2. If this one is 105, okay, then 90 has to be here. This has to be pi over 2, okay, because it is very near to this one. See that? So my answer here has to be, I'm going to take now 0 to pi over 2. So the shaded area, R will be equal to the integral from 0 to pi over 2. And then we have sine of 2x, then plus sine squared 2x. In trigonometry, when we get even powers of cosine or even powers of sine, we use the double angle expression for cosine. So we know that cos, okay, let me write it here, from cosine of 2x, which is equal to 1 minus 2 sine squared x. When you make this one the subject, sine of x will be equal to, remember, bring this one here, take this one here, so it will be 1 minus, then the cos 2x, and then after you divide through by 2, okay? So you can see that this one is x, but this one is 2x. So that means if I have sine, no, this is sine squared. If I have sine squared 2 of x, I'm going to double that angle. It is going to be cos 4x, then out of 2. So that means our shaded area here, we are going to have the integral from 0 to pi over 2, and then here you have sine of 2 of x, then plus now a half into 1 minus cosine of 4 of x, and then dx. When we integrate sine, we get a cosine, okay? We get a cosine, and then we divide by the derivative of that angle, okay? So when you integrate sine, you actually get a negative cosine, okay? Negative cosine of 2 of x, then you divide by 2. Because when you check in the list of formulae, we are looking for this is differentiation, now the integration. When you integrate sine, you get a negative cosine. But that is when the angle is just, the coefficient of the x is 1. So we use the chain rule, and then we divide. For integration, we divide. And then for differentiation, we multiply, okay? Now, coming back to this, so this is negative cos 2x over 2. And then also here we shall have that a half, leave it. Then inside here you will get x, then minus. When we integrate cosine, we actually get a positive sign, okay? We get a positive sign. But since already this one is a negative, so we just leave that one there. And then we divide by 4, the derivative of that angle. Then we put the limits, pi over 2 and then 0. Now, when we put the limits, we are going to have cos, this is negative cosine of, when you put pi over 2 here, you'll get pi, then over 2 plus a half, then into, this will be pi over 2 minus pi over 2 times 4, that will be sine of 2 pi here over the 4. Then after that, to go to the lower limit, we subtract. So put 0 here. Cos of 0 is negative 1, okay? Is 1, but there is a negative. And then plus, this is a half. Of course, inside here, 0, 0. Then cos of pi is negative 1. So times the negative, that is a positive a half. Then when you multiply here, you will have now pi over 4. And then here, we shall have sine of 2 pi. Sine of 360 is a 0. So this one goes. Then minus, of course, here, shall have a plus because the negative affects the negative. Okay. Then after that, this one gives us actually 1 over a half plus a half is 1. Then plus pi over 4. So this has to be our answer. Question 7. Let f of x equal to 5x squared plus 8x plus 5 out of 1 plus 2x into 2 plus x squared. Part A, express f of x in partial fractions. Now, if they give you in partial fractions as the first part, expect the next part to be from binomial expansions or from integration. But since we have already seen integration, this one can be binomial expansion. Now, our f of x, now this 5x squared plus 8x plus 5, then out of 1 plus 2 of x, then 2 plus x squared. This one is going to be a over 1 plus 2x because we are seeing a linear factor in the denominator, and this is a quadratic factor. So for the quadratic factor, we are going to have bx plus c, then out of this 2 plus x squared. You don't need to waste time. This is the LCM here. So this LCM divide by what is here. That means this one will cancel with this. You remain with this, and then you multiply it with a. Okay, so we are going to have this is squared here. Let me first clean this. Now we are going to have, you just said this times that, and then this times that. Okay, so we have a into 2 plus x squared, then plus bx plus c, then into 1 plus 2x, which is actually equal to the numerator 5x squared plus 8x plus 5, because all of them are over this one here, okay? It will also be here. So they just cancel out. That's why we just equate that to the numerator. And then we look for values of x that are going to terminate terms here, okay? So suppose x, okay, if x is equal to, I can equate this one to 0, and then I get a negative a half. So if x is equal to negative a half, that means this whole thing will go, okay? And then I remain with this one here. So a into 2 plus negative a half squared then shall be equal to 5. You put negative a half here squared plus 8 into negative a half and then plus 5. Okay, so what do we get? Just get your calculator now. It's a 2 plus, this will be a quarter, 1 over 4. This one gives us 9 over 4. So we shall write 9 over 4 of a, then is equal to, you also go the other side and you put 5 into a quarter, because a half squared is a quarter, and then plus 8 times negative 0.5, that's a negative 4. Sorry, this is 8 here, and then we now add a 5. So it gives us also 9 over 4. So 9 over 4. That means when you divide all through by 9 over 4, our a becomes a 1. Remember, the mandate is to find the a, b, and the c. And then next, I can use another x value that can terminate one of them. I can use 0. If x is equal to 0, that means this b here will go. Okay? So that means we shall have 2a, then plus c, which is equal to now 5. So c is going to be 5 minus 2a, which a is 1. So that means our c is going to be equal to 3. Now, since the terms that I can use, since the values of x that I can use to terminate the terms are done, then I can use any other value, okay, of x. So now what we can do, we can just say, if you use the simplest one, like if x is equal to 1, so put here where a is 1 squared, that one will give you 1, then plus 2, that is 3a, then plus, when I put 1 here, it will be a 3, okay? So 3, then times b, so we shall have 3b plus 3c, okay, which is equal to, put 1 here, that will be 5 plus 5, 10, plus 8, 18. So that will be 18, we shall equate to 18. When you divide all through by 3, you get a plus b plus c, which is equal to 6, right? And then we are looking for b. So our b will be equal to 6 minus the value of a, which is 1, minus the value of c, which is 3. That means b is going to be equal to 2. Then you can conclude and say f of x is equal to a, which is 1, out of the linear factor we have is 1 plus 2x, then plus b, which is 2 of x, then plus c, which is 3, then out of 2 plus x squared. This is your answer. Part B, hence find the coefficient of x squared in the expansion of f of x. So you see, now this is binomial expansion. So first write your f of x, which is now equal to 1 plus 2x to the power of negative 1. Then we have the 2x plus 3. You also put 2 plus x squared power negative 1. So let us first expand 1 plus 2x to the power of negative 1. Okay, let me first put off this. We are going to use binomial expansion. Okay, so using binomial expansion, remember these ones are all given in the list of formulae. Binomial expansion, we have, if I have a plus b, the general one, power n, then I'm going to put the power on the first one, then b is to the power of 0, then 0 factorial. The power of b is the factorial, okay? Then you keep on differentiating a, you reduce the power by 1, so multiply here the n, then reduce it by 1, then that 1 it has lost now is picked by b, then 1 factorial. Then now drop again n into n minus 1, then a to the power of n minus 1, then b, this will be n minus 2, n minus 2, then b squared over 2 factorial, like that, and you continue. So now we have 1 plus 2x to the power of negative 1. We shall have this one expanded as 1 power negative 1 into 2x power 0 out of 0 factorial. So since they said the coefficient of x squared, x cubed, I need to expand up to the term in x cubed. Then plus, drop the power negative 1, then power negative 2, then this one is 2x, then to the power of 1 over 1 factorial, then continue. This will be now negative 1, then times negative 2, then now 1 here is going to be to the power of negative 3, then the 2x will be to the power of 2, then over 2 factorial, and then the last one here is going to be negative 1 times negative 2 times negative 3, then 1 is now to the power of negative 4, and then 2x here, then to the power of 3 now out of 3 factorial. Okay, now this one is going to give us 1 power n number is a 1. Okay, 0 factorial is a 1 because there is only one way of arranging an empty set. And then this other one is going to give us a minus 2 of x, and then the other one will give us a 4x squared. Okay, remember this one is positive, so it cancels with this one. 2 factorial is 2, and then when you square here, you get 4x squared. Okay, so we shall have this one here, 4x squared, then minus, this will be 8x cubed. Then we can also go to this other one here, the 2 plus x squared is power negative 1. So we shall have 2 here, power negative 1. Then you put x squared power 0 over 0 factorial. Then now drop the power negative 1, 2 power now negative 2. Then x squared now power 1 out of 1 factorial. Okay, then I think this one is enough. I don't need to add on any other, because if I add on, that means x, the power of x is now going to go to 4, and yet I'm interested in the one that ends in power 3. So that's enough. Now I go back to my f of x. So my f of x is now going to be 1 minus 2x plus 4x squared minus 8x cubed. Then this one is multiplying nothing, then plus 2x plus 3 has to multiply. By the way, this one here is giving me a half. 2 power negative 1 is a half, then minus a quarter x squared. So this one is a half minus a quarter x squared. Okay, so the term, I don't need now to expand each and everything. I just need the term in x cubed. The term in x cubed, we look at those values that are going to multiply, and then we remain with x what? Cubed. So here I will only pick this one here. It will be negative 8x cubed, then plus. This 2x is going to multiply with nothing. This 2x here is the one which is going to multiply with the negative a quarter of x squared to end in x cubed. Okay, so these are the only terms. So I'll have negative 8, then minus a half, okay, of x cubed, because 2 times a quarter is a half. Okay, and then putting this together, negative 8, 8 times 2, you get 16, then plus 1, that's 17. So you are going to get negative 17 over 2 of x cubed. So this therefore implies that the coefficient, you can conclude the coefficient of x cubed is equal to negative 17 out of 2. Don't write, some people write this, they put this one off and they write x cubed is equal to negative 17 over 2. No, they asked for the coefficient. Okay, so that is going to give us that. Question 8, part A, this one is coming from complex numbers. Given that z is equal to 1 plus yi and that y is a real number, express 1 over z in the form a plus bi, where a and b are functions of y. So 1 over z is going to be equal to 1 over 1 plus yi. Now here we rationalize the denominator. So what do we do when we rationalize the denominator? You are supposed to multiply the numerator and the denominator by the conjugate of the denominator. So what is the conjugate of this one? If we have the imaginary part is positive, then the conjugate, the imaginary part, is going to be a negative. So that's what we multiply down here and also up here. Now, when we do so, it's like we have done nothing because these ones can easily cancel. Okay, so it's like we have done nothing. Now we open the brackets. This will be 1 minus yi. Then out of, you get 1 times everything here. So we shall get minus yi. Then yi times 1, that is yi. And then yi times negative yi. So we shall get negative y squared I squared. But you know that I squared is equal to negative 1. So that means this one will be a positive. So we shall have 1 minus yi. Then out of 1 plus, of course, these ones go 1 plus y squared. So this therefore implies that 1 over z is actually 1 over 1 plus y squared, then minus y out of 1 plus y squared of I. So this means this is our A, and then this is our B. So that is our answer. Then part B, show that A minus a half bracket squared plus B squared is equal to 1 over 4. So our A, remember, is 1 over 1 plus y squared. So I'll substitute here and I say 1 over 1 plus y squared minus a half, okay, squared. Then plus our B is negative y out of 1 plus y squared, okay. This one is supposed to be squared. So what do we get? Now, you should know that now this one is a square. We are expanding this. You know that a minus b squared is a squared minus 2ab, then plus b squared. So that means here I'm going to have 1 over 1 plus y squared. I square it. Then minus now 2 times 1 over 1 plus y squared. Then times negative a half. See that? And then plus now this a half squared. Then of course this one for b, when you square a negative, it becomes a positive. So that is y squared. Then out of 1 plus y squared, also squared. Now when you look at all of these ones in the denominator, by the way, this 2 here is going to cancel this one here. So let me first simplify this. This is 1 over 1 plus y squared squared. Then it will be a plus because a negative and a negative, it becomes a positive 1 plus y squared. And then plus 1 over 4. Then plus y squared over 1 plus y squared squared. The LCM, since this one goes into this, okay, then the LCM is going to be this one here. So our LCM is going to be 1 plus y squared. So I write here 1 plus y squared divide by this one here, because then you get 1 here, and then this one divide by this. So this one actually cancels 1 there, and then you remain with that 1 plus y squared, then times the 1. So you get 1 plus y squared, then plus. So I'm leaving the plus 4. Let me just leave this one a quarter out, okay? And I deal with this, this, and this, okay? Now, this one divide by this, we shall get, there is a square here. So we shall just get what? Y squared. There is a minus somewhere. Actually, pardon me here. This one is not supposed to be, I already took the negative here. So this one has to be a positive. Okay, because we see a B here. So we are having a minus here. Okay, pardon me here. So we are going to have a minus here. And then when we divide, we shall have that minus. So like that. Then here plus y squared. So when I open, it will be 1 minus y squared, then plus y squared, out of 1 plus y squared, then plus this a quarter. So do you see that this one will cancel with this? Then 1 minus 1 also goes. So we have a 0 here. That means we remain with a quarter, which they told us to prove. Part C, on a single Argand diagram, sketch the loci given by the equations real of z is equal to 1 and z minus the modulus of z minus a half is equal to a half. Now, when you see the modulus signs on one side of the equation or inequality, you should know that that is a circle. Why is it a circle? Let me show you something small here. Suppose we had z minus maybe a plus bi, because z is a complex number, so minus another complex number here. Let's say is equal to like r. Okay. Now z being a complex number, it is x plus iy. Okay. Now I can put it here and I say x plus yi, then minus a minus bi, then which is equal to r. Then x and a are the real values. Then we can have the imaginary y minus b there. And when we are getting modulus means the length. So that means we shall get x minus r. So we can actually undo this one here. The length is going to be this one here, squared plus y minus b, also squared under the square root. Okay. Now when you square both sides, you are going to get x minus a squared, then plus y minus b, okay, squared, which is equal to r squared. Do you see that this is the general equation of a circle? General equation of a circle. So the moment they give you the modulus signs on one side of the inequality or the equation, you should know that that is a circle. Okay, that is a circle. Okay, so now we are going to pull off this one here, and now we shall have this one here for the modulus of z, then minus a half, which is equal to a half. This one I can write it as z minus, just like the other one, it is going to be now a half, then plus 0i. Okay, so that it doesn't change the meaning. I must have, I always say create a negative of the complex number, so which is equal to a half. So this is a circle of radius a half, center, the center is a half 0, okay, inside here. And then when you have the real of z, because on an Argand diagram we have the real here, it is like the x value. So real of this is equal to 1, it's a vertical line. Okay, it's a vertical line. Now we are going to draw this one here. I can have this one here. Then I get this and I write real of z, and then this is the imaginary of z. Then to produce something very, very, very beautiful, you can use your compass. Okay, you can use your compass and then you draw a very good circle. So if this is, I can say if this is a half, and then this is 1, then this is maybe 1.5, like that. and then up this way we also have a half, and then down here we shall have negative a half, then this way negative a half, negative a half. Now the center is a half zero, so a half zero is here. Then after that the radius is also a half, so I move this way a half, I move this way up a half, then down I also move half, and then here half. That means when you are drawing, this circle of yours must be a tangent to the origin here, then you also bring it here, passes here, and also this line here, it has to be a tangent, shouldn't protrude through. Okay, let me repeat this one, it shouldn't go beyond this one. Okay, when you use a compass, it becomes very, very clean. So it is here, I can take it just like that. And that is my circle. You don't need to be so accurate, but we are looking at these points here being tangents. Okay, the circle being, these lines here being tangents, and also this one, it's a tangent, so they are meeting the curve at that one point. Okay, the next real of z is equal to 1. So 1 is here, then now you draw this one here, passing through this. So you see, it has to be a tangent there. But if you draw when it is like this one here, then that means that you're going to, the circle has gone all through. So there you lose a mark, so it has to be a tangent. And then here, you can label this one as real of z, which is equal to what? 1. So that is going to be our circle. All right. Next, part D, the complex number z is such that the real of z is equal to 1. Use your answer to part B to give a geometrical description of the locus of 1 over z. Now, using the general equation of the circle, using the general equation of a circle, we have x minus a bracket square, then plus y minus b brackets squared, which is equal to r squared, and comparing with this other equation here, a minus a half, then squared, plus b squared, which is equal to a quarter, because this was the one in part B. So we can have, this is actually the same as a minus a half squared, then plus b minus 0. If I try to put it in this other format, the equation of the circle, okay? So squared then is equal to, this is a half squared. Now this is a circle, so I can just conclude and say 1 over z is a circle of center a half, 0, and radius a half. Okay, that is the description of the locus. Remember, the locus is a region where the points lie. It can be a straight line, it can be a curve. The straight line can be a perpendicular bisector, and many others. Okay, it can be a half line, like that. Question 9, the position vector of A, of point A relative to the origin O is OA, which is equal to 8i minus 5j plus 6k. The line L passes through A and is parallel to the vector, this one. State the vector equation of L. Now, the vector equation, we can write, if I have a straight line here, and then there is a directional vector moving there. So all I need is a directional vector, or a vector that is parallel to my line. So that means the vector equation is going to be R, which is equal to OA, which is equal to lambda, then times the directional vector. So for this case, this is the vector which is parallel to the line. So that is going to be its directional vector, 2i plus j plus 4k. So meaning we are going to have our OA, which is 8i minus 5j plus 6k, then plus lambda, a scalar. Because if this one is moving like this, vectors are said to be parallel if they are scalar multiples of each other. So to get the directional vector that is going to, or the vector that is taking us from the origin to go to R, which is any point on this line here, okay, we are going to get this directional vector. We multiply it by something to get this distance here. So that's why we say lambda d, okay? And then, so this will be our d here. Let me rub off this. And we shall have this one written as 2i plus j plus 4k. Or you can actually write it like this. You say 8, and this is the one I usually prefer most, and plus lambda into 214, like that. That is the equation of that line. The position vector of B relative to the origin O is OB is equal to negative ti, then plus 40j, then plus 3tk, where t is a constant. The line L passes through B. Now, if a point lies on a line, in fact, let me write it here. If a point lies on a line, comma, its coordinates must satisfy the equation of the line. Must satisfy the equation of the line. Now, we have what we call, I can express the equation of that line in what we call the parametric equation. So the coordinates of this line will be 8 plus 2 lambda. That's the x coordinate. The y coordinate will be negative 5 plus lambda, and then the z coordinate will be 6 plus 4 lambda. Okay, so I'm going to write 8 plus 2 lambda is going to be equal to, this one is the position vector of B, but its coordinates are going to be negative t, comma, 4t, and then 3t. That will be the B. Okay, so the x coordinate on this line is 8 plus 2 lambda. Now I equate that one to negative t, and then the y coordinate is negative 5 plus lambda, which is equal to 4t, and then also the z coordinate we can also equate them, but I can use just these two and I solve them simultaneously. So I can eliminate lambda by multiplying by the coefficient of lambda in the first equation, which is 2, and then here 1. So when I multiply through, I can get 8 up there, then 2 lambda is equal to negative 2, and then when you multiply 2 by 2, when you multiply all through by 2, you get negative 10, then plus 2 lambda, then is equal to 8t. Then when we subtract for lambda to disappear, 8 minus 10, that will give us positive 18. And then negative 1 minus 8, that is negative 9. So negative 9t. That simply implies that our t is going to be equal to 18 divided by negative 9. So t is equal to negative 2. But see, the line M has the vector equation R is equal to 5I minus j plus 2k, then plus mu into a minus minus j plus 3k. The acute angle between the directions of L and M is theta, where cos of theta is 1 over root of 6. Find the possible values of A. So that means it is more than one value. Now, the directional vector, I'm going to use the directional vectors of the line. So the directional vector of line M is going to be that AI minus j here, then plus the 3k. And then the directional vector of L, we have seen it is 2I from the previous working plus j, then plus 4k. So using the dot product, sometimes we call it the dot product or the scalar product. In the list of formulae, you find it when it is written as the scalar product. So the directional vector of M dotted with the directional vector of L, this one will give us the modulus of the directional vector of M times the modulus of the directional vector of L, then cosine of the angle in between them. So we shall have here A -1, then 3. We multiply it with 214, and then we shall get now the square root of A squared, then plus -1 squared plus 3 squared, then times square root of 2 squared plus 1 squared plus 4 squared, and then the cosine of theta is given as 1 over root of 6. Now here we multiply I with I, j with j, k with k. So A times 2, that is 2A, then minus 1 here, then plus 12. This one here will give us the square root of A squared, and then plus 10, okay? And then here we shall have 16 plus 4, that is 20, then root of 21, then times 1 over root of 6. And this one, actually, I can simplify. Root of 21 is the same as root of 3 times root of 7. Then when I divide by root of 6 is the same as root of 3 times root of 2. So this one can go. Then I have root of 7 over root of 2. Root of 7 over root of 2. So here I will have 2a plus 11, which is equal to, now here the square root of a squared plus 10, then times root of 7 over root of 2. And then we can now square both sides such that we do away with the square roots, okay? So we shall have here 2 of a plus 11 squared, then will give us, when I square this side, the square roots are going to go. I will have 10 here, and then times now 7 over 2, okay? Can now cross multiply. So 2 into, this will be 4a squared, then 2 times 2a times 11, that will be 44. Yes, 44 of a, then plus 1 to 1 when you square the 11, and then 7a squared plus 70. That's when 7 multiplies everything in there. When I open the brackets, we get 8a squared plus 88 of a, then plus 242. Then now we bring this on this side, 7a squared minus 70, which is equal to 0. 8 minus 7, here we shall get a 1, so that is a squared, then plus 88 of a, and then 242 minus 70, this one gives us 172, which is equal to 0. This is a quadratic, so you can use your calculator to solve it very fast. Mod, then we go to equation is 5, then quadratic is 3. So this one is 1, the coefficient of a squared is 1, then 88, then 172. So that is -2 and then 86. -2 and -86. So I'll come here and I say a is -2 and also A is negative 86. But if you just write these answers like this right away, you're going to lose a mark, because when they are marking, they say the attempt to solve the quadratic. Okay, so check the examiner this way, bring this one back, and you get the factor from which this root comes. Okay, so it becomes A plus 2. And then this one, when you bring it here, it becomes A plus 86, which is equal to what? 0. And then now here you can get your answers. They said possible values of A, and those are the ones negative 86 and negative 2. Then the last question is from differential equations. They are saying a large cylindrical tank is used to store water. The base of the tank is a circle of radius 4 meters. At time t minutes, the depth of the water in the tank is h meters. There is a tap at the bottom of the tank. When the tap is open, water flows out of the tank at a rate proportional to the square root of the volume of the water in the tank. Then they say that show that the h dt is equal to negative lambda root of h, where lambda is a positive constant. Now, they are saying that water is flowing out of the tank, okay, at a rate proportional to the square root of the volume in the tank. So I'll say dv dt is equal to, dv dt is proportional to the rate which is proportional. So the dt is proportional to the square root of the volume of water in the tank. Since this is a cylinder, volume is going to be equal to pi r squared h. Okay, now that is that. So I remove the proportionality sign, and since water is flowing out of the tank, that means what is remaining there, the volume of the water is decreasing. So here I have to put a negative. So I can put negative k, then square root of v. Okay, so that is that. Then they say that the base of the tank is a circle of radius 4. So if I substitute that r, which is equal to 4 here, we shall have v, which is equal to pi times 4 squared h. And then this one will give us 16 pi h. Now, after that, also they told us that we are supposed to show that dh dt is equal to that. Now, dh dt, okay, dh dt, we are going to use what we call chain rule. dh dt is going to be dh dv, because v is connected to h. You see that? So dh dv, then times dv dt. So that dv cancels, and then you remain with your dh dt. Now, what is our dh dv? dh dv is the same as 1 over dv dh. So from here we can find dv dh. dv dh is going to be 16 pi. Okay, so we shall have dh dt is going to be equal to, dh dv is 1 over 16 pi, then times dv dt. dv dt is negative k root of v. Okay, but what is our v? Our v is 16 pi h, is here. Okay, 16 pi h. Now I can use indices to simplify this. So we can have negative k times, now you have 16 power half, you also have pi power half, you also have h power half, then down here we have 16 pi. You see? Then, of course, 16 power half is 4. Then that 4 can come down here and crosses the 6, so we shall have a 4 down. So we shall have k. Down here, I'll have a 4. Okay? Then, pi, I'll have this pi here, which is power a half. Then remember this one is power 1, so minus 1 there. and then we shall also have h power a half. What did they tell us to show? It is in terms of root of h. Now, I can write this one here like this, negative k, then pi power negative a half, because a half minus 1 is negative a half, over 4. And then I can write this as the square root of h. So this therefore implies that lambda is equal to negative. They actually said it's a negative. So leave the negative there, and then we just take this other part. So lambda is therefore going to be k, then pi power negative a half over 4. So meaning the h, the t, is going to be equal to negative, now that lambda, then square root of h. Part B, at time t is equal to 0, the tap is opened. It is given that h is equal to 4 when t is equal to 0, and h is equal to 2.25 when t is equal to 20. Solve the differential equation to obtain an expression for t in terms of h, and hence find the time taken to empty the tank. Now, what you have to do here when you're solving the differential equations, the first thing to do is to separate variables. There is a mark for that. Okay, so separating variables. Separating variables, remember we are having h, dh dt is equal to negative lambda, then square root of h. So h has to be on one side, so we shall have no equal signs here. We shall have 1 over root of h, then dh, dh, then shall be equal to, like you just cross multiply, take this one here, so negative lambda, and then dt. Okay, now the next thing is to integrate on both sides. So integrating, we have now h power negative a half with respect to h, and then you can put the negative lambda here, you integrate dt. Of course, when you integrate what is differentiated, this one they just cancel each other and you remain with the t. Or there is a silent t power 0 there, so you increase the power by 1 over the new power. Okay, and then it still gives you the t. Okay, now here, remember, increase the power by 1, so negative a half plus 1 over negative a half plus 1. Okay, then here you get negative lambda t plus c. So 1 minus a half, that is a half, so we shall have h power half, then over half, which is equal to negative lambda t plus c. And of course, this one will somersault, and then you have 2 h power half, then is equal to negative lambda t plus c. And they said that when t is equal to 0, h was 4. So this helps us to find the value of c. T is 0, okay, h is equal to 4. So you have 2 times 4 power half, then is equal to lambda here, this one will be 0, then plus c. Now square root of 4 is 2, then 2 times 2 is 4. So meaning now we have 2h power half, which is equal to negative lambda t, and then plus 4. Now we need to find the value of lambda. They gave us t, when t is equal to 20, then h is equal to 2.25. H is equal to 2.25, and t is equal to 20. So substitute 2 into 2.25 to the power of a half. This one is going to be equal to negative 20 lambda, then plus 4. So what will be our lambda? So square root of 2.25, that is 1.5. 1.5 times 2, this one will give us a 3. Then you bring the 4 this side, and now divide through by negative 20. So that means lambda is 1 over 20. Okay, 1 over 20. Now, we now have our differential equation. The particular solution is now going to be 2h power half, which is equal to negative 1 over 20 of t, then plus 4. Okay. Then after that, we are supposed to, they said, find a time, obtain an expression for t in terms of h, hence find the time taken to empty the tank. Now, you make t the subject of the formula, so we shall have 1 over 20t is equal to 4 minus 2h power half. That means we multiply all through by 20, and then we shall have 80 here, then minus 40h power a half. Now, to empty the tank, that means the height or the depth of the water in that tank is 0. Okay? To empty the tank, h has to be equal to 0. So that means t will be now 80. So when you substitute 0, so it will take 80 minutes. Okay? 80 minutes. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. Where you find something confusing, please drop the comments in the comment section. See you in the next videos.